The mole is a unit used to count particles of matter indirectly. So just as you have units such as seconds, Calvin, I don't know how to spell it. The main thing they have here in common is that these are all SI units. Uh, they're units used of an international system, and the mole is one of these units. So the mole is just to account for an amount of substance. If you said, this is you, and you said, I have a dozen cookies, you would have a dozen cookies. And dozen just directly refers to 12. However, if you said, I have a dozen houses, obviously we're talking about different things here with different masses. So, I don't feel like drawing these all out, but a dozen cookies is not equal to a dozen houses. So when we're referring to the mole, it's easy to get confused with this notation, but just remember what I'm saying. It just means amount of substance. What amount of substance, you may say? Well, if a dozen equals 12, what does a mole equal? The mole equals 6.022. There are many more numbers of a mole calculated to a much higher precision, but this is generally what we'll use. You can always look up if you need more significant figures for your equations, but the mole is equal to 6.022 times 10 to the 23, otherwise known as Avogadro's number. And this number is very useful in calculations, particularly stoichiometry. Right now, as I'm telling you, we're going to be using it to measure matter, and I will tell you its further applications in the other four parts of this lecture series. So the mole, as other SI-based units have specific definitions, the mole's definition, aside from being this amount of what? But that's just the number behind the mole. The mole is particularly it's exactly the number of representative particles. I will use this word a lot, so I will write it down, representative particles, because it's just more, it encompasses more topics than just being more specific. So it's defined as the number of representative particles in exactly 12 grams of pure carbon-12. Whether you need to know that definition for a test, now you know. So and that number is 6.022 times 10 to the 23. So representative particles in this case is carbon atoms. Then it's the number of carbon atoms in exactly 12 grams of pure carbon-12 is 1 mole. So some examples of representative particles, because I mentioned that's going to be the general term I'm going to be using from now on. So some examples of, actually I don't need the number there. Are going to be things like atoms, ions, electrons, molecules, formula units, etc. So here I was talking about carbon atoms, but I could be talking about, for example, I could be like if I have the molecular formula for alumina, which I don't off the top of my head, but say I want to find out how many aluminum ions are in alumina. Well, Al plus 3, that's a representative particle. And 1 mole of aluminum ions is 6.022 aluminum ions, which would differ for the amount of moles, but you get what I'm saying. So now we're going to freely convert between the two, between Avogadro's number and the number of particles. So number of moles to number of representative particles, and this is kind of like obvious in a way, it's just basic mathematic calculations. You have the numbers of moles of your substance here. Don't forget to label. I always get points off for labeling, so don't want you guys to make the same mistake. Times 6.022 times 10 to the 23 representative particles over 1 mole. And then you cancel out the moles, and now you have the number of representative particles in your substance that you started out with. And inversely, I don't know if that's the correct way to word that, but number of representative particles to moles would be number of moles. This would be your number. God, that gets so annoying, sorry. 1 times 1 mole over 6.122 times 10 to the 23 representative particles. And your answer would be in moles. So number 1 example would be 4 moles H2O, and I want to figure out how many molecules of H2O, water, that would be. I would do 1 mole H2O cancel out the moles. I would get molecules H2O, and for the second property, which is just it switched around, say we want to do number of representative particles to moles. Representative particles will be atoms, and say I have 1.2 times 10 to the 24 atoms of iron. So atoms OTT times 10 23 atoms Fe for 1 mole, because this is just your conversion factor, that's all it is. And you would get P mole Fe. Paying attention to significant figures here, and you put the .0 because this has 2 significant figures. Might make a completely different topic about that one in the future. I don't know yet. So that's measuring matter, and my next lecture will be about mass in the mole. See you soon.